Hi everyone, welcome to this Snowflake masterclass. We're gonna cover 6 topics across this module. Let's dive into that. Let's know the first topic. What is Snowflake? A Snowflake is a fully managed cloud-native data warehouse platform where you don't install anything and you don't manage any servers. Just log in and start querying your data. It runs on AWS, Azure, and GCP. That's why it is called a multi-cloud supporter. And it is founded in 2012, and it is delivery as a software as a service, and also it is a fully managed. Here is the primary use cases. You can see total 6 primary use cases. We'll discuss this on next videos. Now let's move to the another topic, the Snowflake architecture. The Snowflake architecture is a 3-layer architecture where the top layer is known as the cloud service layer. It is a brain of a Snowflake which manages query optimization, authentication access, control, metadata management and transaction management and query. This all will be done here. Okay, this all will be managed in a cloud service layer. And the second layer is compute layer, where it is also called as a virtual warehouses. It is made up of Snowflake calls virtual warehouses. These are independent clusters of compute resources that actually execute your SQL queries, and multiple warehouses can run at the same time without interfering with each other. And the bottom layer is storage layer, where all data lives in a compressed columnized format on cloud object storage like S3, Azure Blob, and Google Cloud Storage. Okay, let's know another topic, virtual warehouses in Snowflake. A virtual warehouse is a compute engine that runs your queries. You can have multiple warehouses running at the same time on the same data. Different teams get their own warehouses. No one slow down anyone else. Okay, a virtual warehouse is here. You can see a compute resources, CPU, memory, and SSD. And here is a virtual warehouse sizes: X small, small, medium, large, X large, 2X large, 6X large. This will be costed according to the virtual warehouse size as you selected. See, for the X small, you will cost as a 1 credit per hour. For the small, 2 credits per hour, and for the medium, 4. And you can see it is increasing by the increasing of the sizes: large 8, X large 16, 2X 32, and 6X is 150. 512 credits per hour. It's very hard. Okay, let's know the other topic, how Snowflake stores data. See, what is micro partitions? Snowflake automatically divides all tables data into immutable micro partitions. Immutable means it cannot change. Okay, it is not editable. Each micro partitions is 50 to 500 MB uncompressed data, and the data is stored in a compressed columnized format with each partitions. And Snowflake maintains metadata about every micro partition: minimum, maximum values, distant count, and null count. This all will be included. The metadata enables partition purging and scanning only relevant partitions. As you can see here, for like an example where date equals to 2024 third month. See, here is a 12 months, but it scans only 1 month. Okay, you got a thing. So scanned one partition out of 12. See, here's the 12 partitions, but I'm using this where condition so that it checks only the partition which contains the third month. So 1 2 3 4, like total 12 partitions are there here. In that, only one partition is taken, and the data which is stored in this third month, that data I will get. This is about this micro partitions, how it is pruning the data at all. Let's move to the another topic, multi-cluster warehouses. At the same time, Snowflake automatically adds more clusters. Okay, no queuing, no waiting. When the load data goes down, it removes the external clusters automatically. See, you will understand by seeing this diagram. See, without the multi clusters, only one cluster is there. The huge number of users loading the data, but the users will query the different way. So if the user 1 is querying the data and the user 2 also querying the data, okay, after the user 1 completes the query, then the user 2 queries will be executed. So this is like waiting thing, right? So that is not possible without by the one cluster. So by using this multi clusters, the cluster 1, cluster 2, cluster 3, see, the cluster 1 will stand for the user 1, and the cluster 2 will stand for the user 2, and cluster 3 will stand for the user 3. So they query independently, and by this multi clusters they will get the data easily, and they can query the data in immediately. The immediately results also will be occurred. This is all about this topics. So yeah, that's all guys. Thank you for watching. Stay updated for the next topics. Okay, I will come up with the examples also in future videos. Please be stay tuned. Bye bye.